All right, well, thank you. Can you hear me all right?
Yes.
Perfect. All right, so I'm going to switch over to a little bit more of a social science type aspect right now, but it's not totally social science. Oops, um, it's really talking about where the physical science meets the social science. And I think that's one area right now where we're really growing as an agency and really evolving. And I think it's also one of those areas when it comes to our mission that you can really get the most effectiveness out of what we're doing. We're, in this case, talking about integrating mesoanalysis into messaging, marrying those two types of sciences, I think really has the most potential there to get people to take life-saving action. And so when I'm talking about severe weather risk communication, of course, what we're all well used to is the SPC Convective Outlook. And in this talk, I'm not trying to at all slam the convective outlook, just pointing out that every single form of communication has its benefits and limitations. And so we shouldn't just be sticking to one type of communication. And the convective outlook is great. It's been around for many, many years. It's well ingrained into our culture as an agency and as a weather enterprise, really. But we have to keep in mind when we're using the convective outlook to convey severe weather risk, we have to remember what it's designed to do and what it's not designed to do. What it is designed to do is communicate basically the probability of severe weather occurring in an area, and there's a factor of intensity as well, which is great, especially as a situational awareness type communication method. This is the example from about a year ago when Lee County, Alabama had that deadly tornado. They were under an enhanced risk. And keeping in mind that when you're looking at the convective outlook, there's a strict definition to what you're looking at. And by most cases, the severe weather that we get falls pretty nicely into these definitions. Of course, SPC does verify these, and they typically verify very well. But when we're actually talking about risk to someone's life and safety, there's a lot of other factors that we have to keep in mind. And so that's what I'm going to be talking about in this talk. So for example, yesterday, parts of Tennessee got upgraded to a moderate risk. And that got people really worked up because that color red, that word moderate, which that might not mean anything to them, but just seeing that color red, they thought, oh, the threat for tornadoes is getting higher, when no, that moderate risk was issued for damaging wind. So just because maybe you've got a moderate or a high case that warrants a moderate or high risk for damaging wind, well, if someone's in a really well-built office building or school or home, that threat to their safety might be more of a marginal or a slight versus an environment that warrants a marginal or slight risk, maybe for damaging wind. There's some people that could present a high risk to their safety, and I'm going to talk about that as well. Or I'm also going to talk about this. Maybe you're in a marginal or slight risk because the chances of a tornado are low, but if it does happen to you, then all of a sudden you're in a high risk for safety. So things to think about as we move forward. So things that we're not addressing when we're talking about a convective outlook: understandable risk assessment for most people. The wording can be confusing to the general public. To a lot of people, the word moderate sounds like moderate, which means get better. That doesn't sound like a high risk to them. Enhanced, on the other hand, sounds worse to a lot of people. And there's a lot of talks out there, a lot of great social science talks showing how people not only are confused by the words that we use, but the colors don't always make sense to them either. Severe weather type, like I mentioned, that moderate risk yesterday got issued for us for damaging wind. That doesn't necessarily resonate with people that we're not talking about a high tornado risk in that type of threat. And this is very important, uncertainty and how the forecast could change. That's important when we're messaging risk. And the convective outlook is not designed to do that. And then even more important, social science risk communication concepts, we need to start communicating impacts. Who is at risk? What action should they take? Those are all very, very important, and reasons that we shouldn't solely rely on the convective outlook to convey our severe thunderstorm risk. In this graphic here, I'm not picking on Birmingham. I cropped out the right side of their slide where they did mention a lot of these things. So it was a good graphic on their part. They did not just rely on the convective outlook itself. And as we're also communicating severe thunderstorm risk to our users, we have to keep in mind some important decisions a lot of people have to make. And so the better that we can more directly address these decisions, the more effective our communication method would be. So for core partners, emergency managers, law enforcement, they need to know, do I need to staff up operations? If it's a nighttime event, do I need to keep myself available and not go to bed? Do we need to plan for emergency operations? Maybe a big state fair, do we need to work on delaying or canceling that? And the public, they've got important decisions to make as well. If they need to change their plans, if they need to prepare to take shelter, a lot of people, especially down here in the South, they don't have shelter readily available. They need to know if they need to prepare for that. And sometimes that might include going somewhere else to stay safe. So using an example here, I gave this example from several years ago now. This was a real example back in 2015, where there was a moderate risk over parts of western and central Oklahoma for a supercell and tornado outbreak expected out there. That was then expected to transition into a QLCS as it moved into eastern Oklahoma, where they had an enhanced risk for that, and then slight and marginal risk as we go into a decaying line of thunderstorms overnight. And that's basically what happened. Tornado probability, they did have a 15% hatch to align with that moderate risk, and then lower probabilities further east. And this type of outlook is good when you're looking at what it's designed to do. So where you have these supercell tornadoes, you have the potential for numerous long-lived tornadoes. Some of them could be strong, obviously potentially deadly. So that's a good risk to convey to people. But now let's think about these QLCS tornadoes that TJ just kind of touched on. Those also could be numerous. They're probably going to be shorter lived than your supercell tornadoes. On average, they're going to be weaker than your supercell tornadoes, not all the time, but they're usually going to be accompanied with less lead time, maybe no warning at all. A lot of times these happen at night. Those are potentially deadly factors too that we have to keep in mind with our risk communication. And so we've got this gentleman here out. We've all seen this image, I think, where he's out mowing his lawn. Maybe this was a moderate risk day with that supercell, but he's got plenty of time, obviously, to visualize the tornado, know what his risk is, and to take the appropriate action after he's finished mowing the lawn. Versus maybe a QLCS type tornado that spins up very quickly. Here's one ripping through a Kmart parking lot. Someone who's in a car or maybe walking to their car is obviously at a much greater risk at that moment than this guy mowing his lawn, but maybe that was a slight risk where he's in the moderate. That Oklahoma example I used, I happened to be in Tulsa on that day. That's why I use that example. And this was a good friend of mine's wedding in an outdoor tent. So we were obviously watching the weather very closely, but just think of what could have happened if just a weak tornado would have hit this tent with all these people who I know inside of it. That could have ended up terribly. So treated this event, even though the tornadoes would have been weaker, maybe, just like we were in that moderate risk. And an EF2 tornado actually did end up striking the town of Broken Arrow, very close to where this was. So getting back to weak tornadoes and damaging straight line winds, like I said earlier, depending on where you are or where you live, even damaging straight line winds or a weak tornado could be potentially deadly. And these are all deadly incidents that happened either from a weak tornado or straight line winds. I know at least two of these are from Central Region. We've got the Branson duck boat incident that we're all familiar with. That was straight line winds. This was an event in the lower left from St. Louis. I think that was outside the Cardinals Stadium a few years ago, where I believe that did kill somebody when that tent, I think it was sub-severe winds that might have done that, blew a tent over. And a big awning or tent like that can obviously kill somebody if it's blown around. So when we're talking about risk communication, we have to keep in mind different populations have different vulnerabilities. And also going back to the QLCS tornadoes, those on average are going to have shorter lead time. Well, there's people who need to know that. There's people who need more lead time. And if we're telling them that they aren't going to have much lead time if there is a tornado, that could dramatically impact their decision making. Like mobile home residents, they need to leave their mobile home to get to a sturdy shelter. Large venues can take a long time to evacuate. And we know that here in Nashville with things like the recent NFL draft and CMA Fest, big venues, it takes 20, 30 minutes to get all these people who a lot of times are drunk to a sturdy shelter. And it's not just severe thunderstorms that these concepts apply to. We also need to think about flooding. That can be just as deadly sometimes. I gave this talk to Marquette last year, and I thought this was a great example from up in their area where they were under a slight risk for the WPC excessive rainfall outlook, which obviously mirrors the convective outlook very similarly. And again, this is looking for the number of, or the probability of exceeding flash flood guidance within 25 miles of a point. That's the definition. So here in this case, in northern Wisconsin, we have a higher likelihood of that occurring where we're expecting higher rain. But that doesn't mean that you can't get deadly flash flooding in that slight risk. And this happened to be the town of Houghton, Michigan in June a couple of years ago, where they were in that slight risk. That's where the star is in the very far northern UP, and had a devastating flash flood that just tore apart a lot of the downtown area of Houghton. And when we're dealing with excessive rainfall, a lot of times we just use QPF maps, which are fine to give an idea of how much rain could be expected, but that's not accounting for how the forecast could deviate. And if you look at what actually happened rainfall-wise that day compared to what was forecast, it was on average as a whole a very good forecast, with one exception. And over the town of Houghton, there was a line of training storms that came in, very hard to forecast that kind of thing, but they ended up with 4 or 5 inches of rain and a devastating flash flood, even though they were in a slight risk. So it was a great forecast for the most part, but that one exception happened to be deadly. And so how do we pick up on that? And then how do we communicate that, where again, how the forecast could change, what would the impacts be, and who is at risk and what action should be taken? That's also applicable to flash flooding. In dealing with vulnerable populations with flash flooding, again, it depends on where you're at usually. If you are a resident along a creek or stream, you're at risk. Motorists, they could be safe 99% of their drive, but that 1% where they happen to be crossing a creek or river could be deadly to them. People out camping, float trips, they're very high vulnerable populations out there. And urban areas, those flood very easily. We've got very flash flood prone areas in central region. And a lot of times, a lot of these people don't know they're vulnerable, especially the people who are visiting like recreationally, or the people driving around, they don't know that they're vulnerable. And that's something that we have to keep in mind. So as we try to go beyond just these meteorological outlooks, again, it's not because they're not good, they are, but they have their limitations. So how do we go beyond those limitations? Two of the most important components of risk communication, if you ask most social scientists out there, is identify who is at risk and then provide them an action. And there's a lot of really good social science research out there that says providing that action makes it much more likely that they will take it. A lot of times we just infer to them, we'll provide them a level of risk and then leave it to them to infer what they need to do. There's some good science out there that shows we should really be doing the opposite. Tell them what they need to be doing, suggest what they should be doing, and from that, they will infer how bad the risk is. Other items such as when should they do it, that's important. What if the forecast were to change for better or for worse? That's very important to communicate. And especially with our core partners and those who need to make preparations, what is the worst they should be prepared for? And what are the odds that that could happen? To do that, it requires, this is where the physical science comes in. This is where your mesoscale analysis, if done correctly, can really help to answer these questions. And one reason why we need to be doing it for every event, even if we're only in a slight or marginal risk, is what if it changes? And I just throw this out there. We've got this obviously very bad pandemic going on right now. There's a lot of risk communication going on. And this time we're not the ones communicating it, we're the ones receiving it. And if you could look at a map like this of how many cases are out there, maybe you can compare this to a severe weather map, storm report map. Is anyone out there trying to draw a convective outlook or a coronavirus outlook based on this map? No. What we've been hearing is exactly what the social scientists tell us to do. Who is at risk? In this case, it's older populations, and those with pre-existing conditions are the most at risk. And then what should they do? Wear your mask, wash your hands. We've heard that a million times for good reason. Social distancing. We're hearing that over and over, and it's working. A lot of people are taking these actions to heart. So now taking this concept back to weather. So I want to show you a few examples of success stories from when communicating in action seems to have resonated with our users. This was back when I was at Pleasant Hill forecast area a few years ago. We had a QLCS forecast that night. This was early March of 2017. And one of our messages then was that with this QLCS coming in late evening and overnight, that it's going to be moving very quickly. It's going to be evolving very quickly. And we knew with the amount of shear out there that we could get these quick spin ups with almost no notice. And so one of our messages was, we could be looking at damaging tornadoes with only 5-10 minutes of lead time. Well, what's one part of the population that's very sensitive to that low lead time was mobile home residents. They need to leave their mobile home, sometimes get in a car and go to a relative's house or somewhere with a sturdy shelter. And they might not have enough time to do that if we're only giving them 5 minutes to do it. So our message that night to mobile home residents was, if you don't have a designated shelter in your community, this is a night where you might just want to consider spending the evening somewhere with a safe shelter until the storms pass. So a friend's house or a relative's house. And just looking at some of the comments, we saw a lot of comments like this where people were tagging people and either asking to come over or inviting people. And that's very encouraging to see. And a lot of the shares were doing that as well, tagging people. So instead of letting them infer that they need to do this, when we actually outright told them that they had to do that, we saw evidence of them doing that. And you like to think, if this many people were doing it publicly in our comment section, how many people were doing it not publicly by texting and calling? You would hope that a lot. We actually tried this yesterday, 2 days ago, with the risk that we had down here. Thankfully, it missed our area. Areas to the south weren't so fortunate. But the forecasters who were working over the weekend tried that again, and you'll notice there's no map here. They didn't need to put out a map because they'd applied to our whole forecast area. And they're saying what you can do now to prepare for the severe weather potential. If you live in a mobile home, consider finding a safe place before tomorrow evening. And if you know somebody who lives in a mobile home, you can offer shelter. I thought that was a great example of what to do. And we, again, saw people in the comments, and this person saying, I shared it with my county, and then someone else saying, I'm going to my pop's house tomorrow, which happened to be Easter. Now, granted, with COVID-19, this is throwing a big wrench into things because it's, do I stop socially distancing to keep myself safe from the tornadoes? It's something that we don't really have the answers to. It's very complex and unfortunate. But it did work. Thankfully, we didn't have the tornadoes here to deal with like they did further south. Another message here was from a couple of years ago, another nocturnal QLCS. These are really tricky to message. But in this one, it was coming in later in the evening and overnight, when a lot of people would be asleep. So our message here was, be sure you can be warned while you sleep. Notice this graphic has no mention of what risk level we were in. It happened to be enhanced, but we're not saying that. We're getting straight to the point. Make sure that your phone is on and not on Do Not Disturb, or that your weather radio is plugged in so that you can get a warning while you're sleeping. And from that one, if you just compare the Facebook engagement statistics compared to other graphics that we put out, it blew away everything else we put out, reaching 763,000 people, almost 750,000 people. Compare that to the Tornado Watch or the Convective Outlook. We did message the Convective Outlook. You can see as that third one, nowhere even near the engagement that it got when we explicitly told people what to do. And I think it's right what the social science says. You tell people that they need to leave their phone on, they then infer that there is a threat for tornadoes because you're telling me that. And it does seem to work. Getting back to flooding, this was another case from a few years ago with Tropical Storm Bill that came up through the Ozarks into eastern Missouri. This was a weekend in June. And anyone familiar with Missouri knows that the areas where that heaviest rain is tracking is very popular for float trips and camping trips, which right there are vulnerable users. So putting out this graphic of QPF, it's very standard when we're expecting an event like this, and it's fine. But looking at some of the engagement, when all we're basically saying is, here's a lot of rain, watch out for flooding. Yeah, people are getting the message, but some of these are not taking it so seriously. I can go outside with a bar of soap and shower. According to this, we're screwed. Wettest float trip ever. that doesn't sound like someone who's really taking it seriously. Same graphic, QPF, but this time we singled out people who are vulnerable. In this case, it was anyone taking a float trip on all of these rivers that people like to go floating on in Missouri. And even though this came from Kansas City, and it's not really impacting Kansas City, a lot of people that live in the KC area go to these areas for their weekend float trip. So that's why we wanted to single it out, even though it wasn't in our forecast area. And when we singled out these rivers, like the Merrimack, like the Niangua, like the Elk, people took it a lot more seriously. And you got a lot more comments saying, okay, we canceled our trip down the Knoll because of this. We canceled our trip on the Jack's Fork. I'm calling the campground. So people taking it a lot more seriously and taking a good action in response. So tying it into now some mesoanalysis into how that can be incorporated into messaging. This was from last year, back in February, when we had a potentially significant rainfall event moving into much of Tennessee. And so our mesoanalysis looked at, we've got this strong low-level jet interacting with a nearly stationary boundary. So stationary that this loop down here shows 850 convergence lined up over southern parts of Tennessee for 24 to 36 hours. That's a pretty big deal. Looking at other things like low-level moisture transport, all these other things, the amount of moisture in there, your warm cloud depth, all these different ingredients that you look for heavy rain, all of it was lining up for a potential major hydro event. And it had already been raining, and they already had water rescues before this was even moving in, so that complicated things even more. Then looking at how to communicate your uncertainty, looking at things like ensembles. This is the GEFS postage stamp ensemble output down here in the lower right. I know it's hard to see, but basically when you're looking at bright pinks and blues and whites from every single ensemble member, in this case showing the potential for anywhere from 4 to 7 to 8 inches of rain from every single member, that can then start factoring into your messaging because it's more likely. It's not, maybe not possible, but it's likely. So here's what we ended up putting out as a graphic like this. And we came together as an office to talk about exactly what words we wanted to use. Do we want to use the word urgent? Do we want to use the term life-threatening flooding? Do we want to say possible or likely? Well, because of that ensemble output, we decided let's say likely. And the text that accompanied it here, you can see we, in the first sentence, we said this is a serious situation. And then we gave actions. Driving will be dangerous, that's an impact. And then an action, if you live near a creek or river, you now need to be ready to evacuate before the rain even gets there. That's how confident we were that it was likely something could happen, that they should just be ready to evacuate right now. And they needed to. They ended up having to evacuate, and a lot of the rivers went into major to near record flood. This was a success story in our mind because, one, nobody died. We had no fatalities. I don't think any injuries either. And then when the media went down there, we had our media workshop a couple of weeks later, and some of them said that they spoke to a lot of these residents who had to evacuate, and they mentioned this exact graphic that we had put out, that they had seen it and that they were ready to evacuate, and they took it to heart. So that was very encouraging. It's one thing to put this graphic out. It's another thing to hear that people actually saw it and took your recommended action seriously and did it. So again, things that we use, terms like urgent, life-threatening, serious situation, evacuate. What we didn't use, we didn't mention QPF. We didn't put the WPC flash flood risk map out, which happened to be high. Now we did put graphics like that out, just not in that graphic. And again, if you look at the social media engagement statistics, we did, you can see this fifth one down, we did put out a map of the high risk, we did put QPF maps out. None of them got even close to the engagement that that post did when we really tried to incorporate some solid social messaging, social science, risk communication concepts into it. So even with hydro or severe weather, you want to think about important decisions people need to make and how you can directly address those decisions. Is it cancel a float trip? Is it cancel a church outing? Is it staffing up evacuations or staffing up for evacuations? And these often are not easy yes or no answers. Sometimes it could be bad. Sometimes there's a low probability of these things needing to happen, but there's still a probability. So how do you convey that? And sometimes we found that it helps if you convey that message with a little bit of meteorology. This is about the only time I ever try to throw meteorology into a message, is if something comprehensible, such as clouds all day will keep the severe weather threat lower. People understand that. People can look for that and they understand that. With this past one, we put out a graphic on Friday saying if the low were to track further south, then we would be out of the risk area. If the low went north toward Evansville and Louisville, then we could have a tornado outbreak. Well, it went south and we didn't end up with anything, which we're thankful for, but people understood that. And we had a moderate risk out there that completely busted, and we haven't heard any blowback or negative feedback, so that's encouraging. Low end severe weather, like I mentioned, that can be deadly for some people, or at least cause injuries. So I gave this talk a couple of weeks ago to Norman, and they provided me this great case of a pulse storm, barely severe, that popped up on an August afternoon with no shear, but it happened to hit the WindStar Casino windstorm. And right as I was doing this, I watched Tiger King, and I was like, hey, this place looks familiar. This is where the people who took over Joe Exotic's tiger farm, they're building that new one right behind this casino, apparently. So anyway, I can go on and on about that. But it happened to hit this casino as they were preparing for a Backstreet Boys concert. And it knocked over some awnings and tents and did end up injuring people. They were in a marginal risk, as they should have been, because it was pulse, widely scattered activity in the summer. That's what the convective outlook is meant for, and it verified completely correctly. But for these people standing outside under an awning, it's not a marginal risk to their safety, it's a high risk to their safety if one of those storms happens to hit. So how do you incorporate your mesoanalysis into the messaging in this event? Well, just looking at a forecast sounding, it's a classic downburst sounding. You've got 3,400 joules of mixed layer cape, maybe not as much dry air in the mid-levels as you would typically look for a classic downburst sounding, but still enough to get a downdraft cape of 1,400 joules per kilogram. That's really good. Your shear all the way through the column, very weak. So identified there that we've got a potential for a downburst. Looking at your Theta-E differentials and buff kit, those are obviously favorable for a downburst environment. So now, using that mesoanalysis to incorporate into our messaging. So doing the meso, what do we know once we've identified that storms that pop up will be the pulsy downburst type? What we know about that is that those can be hard to assess the severity on radar because usually the high winds are happening below radar level. They can develop and evolve very quickly, and they go away as quickly as they sprung up. Because of that, the warning lead time, if we get damaging winds, are going to be very short lead time, if any lead time at all. The highest winds are going to be localized and difficult to pinpoint. And we also know that sub-severe winds in an environment like this are fairly common and easy to get with any storm that pulses up and back down. And now let's translate that to our users. What do we know about a big, large outdoor event that's going on? And they did have this on their DSS calendar. They were providing DSS support. I believe it was off-site, but I might be wrong about that. But we know an environment like this with these big canopies that they are not rated for severe winds. And we also know that crowds tend to rush to these canopies when it's raining because they don't want to get wet. And that takes a lot of lead time to get people out of these crowds or out of these canopies and into a sturdy shelter. And as you saw in that earlier picture, the sturdy shelter happened to be right there, the casino itself. Sometimes it's not that easy. Sometimes you've got these big events without a sturdy shelter nearby, and that can be even more dangerous. But it's going to take some time to get all these people, many of whom I'm sure were drinking. With these events, you usually have people drinking, and that can complicate things even more. That waiting for a severe thunderstorm warning to be issued is not going to provide you the lead time that you need to get an event cleared like that. So put all that together for your core partners. Maybe you'd want a message like this: we're expecting scattered storms today. Any storm that develops in this environment could be capable of wind gusts to at least 45 to 55 miles per hour. Then you might say, so the wind hazards will develop very quickly. Warnings might come with very little lead time. Therefore, we would recommend treating any developing storm as one that could produce strong winds and lightning, and just start taking the appropriate action that you need to do as soon as you see a storm developing. For the public, and this is a crude drawing because I don't have access to Graphy DSS from home, address those who have an outdoor event that they're going to, like an outdoor concert or a state or county fair. and maybe let the people know it's not safe to be taking shelter under awnings or canopies in this environment. So stake out where the sturdy shelter is and be prepared to move to that as soon as you see a storm moving your way. And the Norman office, they did a very good job. This is a timeline of their events that they put together. And here at 5:33 p.m. is when the damage happened. But they had the significant weather advisories and the phone briefings going on over a half hour before that happened. The evacuation order was provided, not going off the warning itself, but by the communication that they were providing to the event. And so they had at least a half hour of lead time to help get evacuations underway. Unfortunately, people were still hurt anyway, but probably that would have been worse had they not gotten that heads up. But you can see here the severe warning itself came out 5 minutes after the damage. So if they had been waiting for that severe warning, probably a lot more people would have been hurt. And so these gotcha events, I think, is when a mesoanalysis really becomes critical. When could the forecast deviate? Yes, when we have a moderate high risk of supercell tornadoes, it's usually easier to know it's going to go on. But some of these gotcha events where they just creep up and you weren't expecting it, like a tornado along a boundary. We've seen that, especially with these land spout events over an outflow boundary or something. That can be a gotcha. These low top supercells, these low CAPE environments, they really get us. And you have to have a keen eye on your mesoanalysis to see just what slight little modification to one little parameter like your surface dew point could have big impacts on what the weather ends up doing. Thunderstorm outflow, heavy rain along stalled boundaries. How many times has that got us where you get training storms over a boundary, a subtle boundary, but just like the Houghton, Michigan example, where all of a sudden you're not getting an inch of rain, you're getting 5 inches. Pulse thunderstorms. You have to do that detailed and thorough mesoanalysis many hours before, hopefully, to even capture what could go wrong, and then keep your mesoanalysis going to see if that is in fact taking place. If you're only relying on SPC and WPC outlooks to do that, you could fall in the trap of getting a preconceived notion in your head and miss important indications that your forecast narrative needs to change. And you could miss the threats altogether. So you have to do this, even in the what looks to be a low-end event. And with that, that will take me to a local event that I'll talk about that TJ touched on, which was that tornado that hit here earlier back in March. And man, this seems like a decade ago now. But I happened to be off that day. I'll just give you a little bit of my perspective. It was a Monday. I had Sunday and Monday off. And so I had briefly looked at the weather on my days off, but I had things to do. I wasn't going to be looking at the weather all day long. So I woke up and I saw a slight risk to our west. And I thought, oh, all right, what's going on with that? And that happened to be the tornado outlook that morning. I am not saying this to critique SPC by any means. I am just saying that this is what the forecast was, because it wasn't apparent to anybody that there was a high tornado threat. So I looked at the 2% and that was it. I shut my laptop and never looked at it again for the rest of the day. Well, later that evening, we did get a 5% upgrade to the thunderstorm outlook, but even that doesn't include Nashville's forecast area. That's Memphis and Paducah, if that's in. So I let my guard down. I, the one giving this talk saying not to rely only on SPC, I relied only on SPC, and I didn't look at the forecast anymore for the rest of the day. And I went to bed at 10 p.m. with the storms not far away, but I didn't think that they would be anything big. So I go to bed at 10. At 12:30, I wake up to my dog. It was my dog who woke me up because he's scared of thunder and was jumping on me. And I sleep with a loud box fan on because I live near train tracks. So I couldn't hear that there were actually tornado sirens going off, as they're not designed to do. And I look over and my phone is lit up and I'm thinking, oh, someone trying to call me? And it happened to be this, a tornado warning. I'm like, oh, how come that didn't sound? And I am groggy. I've been asleep for 2 hours. I was startled out of a very deep sleep. So I am groggy. It's hard for me to comprehend what's going on. So, oh, tornado warning, what's going on? I guess I'll take a look at radar. And I had my phone on Do Not Disturb. In my particular phone settings, my phone wasn't designed to override do not disturb with the WIA alerts. I turned that off. I didn't even know that that was a thing. I had no idea. Now I do. But that was a thing at the time, so I didn't hear my phone go off. So I looked at the radar, and that red dot is where I live in Nashville. And I look and see what looks to be a supercell headed my way. I'm like, oh man. And I'm still groggy, and I can't comprehend. I didn't know that that tornado is on the ground at the time. I didn't know that. At that time, it's producing EF2 tornado damage a couple of miles to my west. And what do? Just as we say not to do, I went out and looked outside, and this was what my backyard camera caught, which is also what I was looking at when I went back on my deck. And it took me a few seconds to comprehend that those flashes, like the one that you see at the bottom, that wasn't lightning, it was power flashes. And that was a tornado on the ground a mile to my south. And so I brought my dog, took shelter, and it was a scary situation. I didn't know exactly where that was tracking. That's looking southwest right there. I thought maybe that was tracking toward me. And I went into my small interior bathroom that I never thought I would have to use and waited for my roof to be ripped off, which thankfully for me, it wasn't. It missed me a few blocks to the south. But it did at that time really damage a lot of my neighborhood. This was one of my favorite bars that I used to go to, just totally torn up. And unfortunately, 2 people died outside of that bar. And so this one got really personal for me. I've never seen a tornado really directly impact my community this bad. And that thing went for 60 some miles, over 60 miles from well west of Nashville across the entire Nashville metro area through the suburbs of Mount Juliet and Lebanon, and kept going 60 miles east of Nashville, mostly EF1, EF2, but some EF3 damage. And then it got its act together again as it impacted the town of Cookeville, which is about 70, 80 miles east of Nashville, and just really quickly spun up to EF4. This town was not even in the 2%. This was in a 0% tornado outlook on that day. And this is what it did to Cookeville. And I went out and surveyed a few days later, and just hearing the stories from people it was heartbreaking to hear them say how they had no idea that storms were possible. They had all been asleep. This couple here on the right, I talked to them, they are standing right there on that slab. They're standing in the bathroom that they were in when the tornado hit. And they were in the bathroom because he was using it. That's not where they meant to take shelter. And it hit before they got to the room that they wanted to take shelter. And it turns out it might have saved their lives because they ended up in that pile of debris back behind them. That's their house. And they ended up in it miraculously. They did not have a scratch. Well, he had a scratch. She didn't. I don't know how they did that, but their neighbors weren't so lucky. And 20 people died in this neighborhood from that tornado. It was very, very sad. And I heard from so many people, they just had no idea. They went to bed not knowing. They heard that storms were in the forecast, but they didn't know it would be that bad. And so from a mesoanalysis perspective, could we have messaged to them that that was possible? I still don't know the answer to that question. Things have been so busy here dealing with the aftermath of that tornado. And then right when things started to calm down where I could go take a deep look, then the coronavirus stuff happened. And I got this case loaded on the West the day before we were all instructed to start working from home. So I haven't had a chance to look at detailed mesoanalysis, but just looking at kind of what the HRRR had, the HRRR hinted at maybe a bowing structure, not something that you would think that I need to message the potential for strong tornadoes. This was an observed sounding from, I think UAH might have released this from just on the south side of Nashville. And yeah, the low-level shear is very, very supportive of a strong tornado, but your thermal environment, maybe not so much. And looking at that little subtle stable layer near the ground, when we get QLCSs around here, and I'm sure it's this way everywhere, a lot of times those little subtle stable layers act against tornado genesis. It's just too much to get what you need going, those dynamics to get a QLCS type tornado. But apparently a supercell can plow right through that, and did. That was not a factor in this case. So that was hard for any of us to comprehend how that would differentiate from a QLCS tornado potential to become a long track violent tornado potential. And this is a graphic that we had put out earlier that evening, just highlighting, we put a low threat for tornadoes. And one could argue that that was right. It was only 2 long track tornadoes out of that whole area. Maybe that did verify the 5%. And this was a tweet coming from someone at SPC, which again, I don't say this critically, just matter of factly, that categorical outlooks are strongly influenced by the expected coverage of tornadoes and do not explicitly communicate intensity nor impacts. Last night appears to have been a series of tornadoes from a single supercell, and that's fine. But again, that's explaining what the convective outlook is meant to do. But then what? Where do we go from there? Because I could not look anybody in the eye, someone out in Cookeville where that EF4 happened, and said, well, we told you there was a 2% chance of a tornado. No, that's not going to cut it. I would never look anyone in the eye and tell that to them. What would I have told that to them? And so I apologize, I'm just going to go full scale feeler here. And looking at some of the people who didn't make it, it's very sad to look at this, but it's things like this that in retrospect make me think, what could we, just in an ideal hindsight 2020 world, what could we have told these people so that they could have been safe? This couple in the upper right, they're the ones that perished outside that bar near my house. He was a bartender. She was his girlfriend, went to pick him up. They got the warning, but she thought she had enough time to go get him at work and get back home and take shelter. Well, they didn't have enough time. The storm was moving 60 miles an hour. So you think about that and you think, well, maybe that could be a message. Don't try to outrun the tornado. As soon as you get the warning, take shelter, because had he stayed in that bar, the bar where everyone was, they were fine. He would have been fine, but she thought she had enough time to go get him and she didn't. Maybe that could have been a message when we're expecting very rapidly moving rapid storm motion. This couple in the lower right in Mount Juliet, a suburb of Nashville, they had a weather radio and it wasn't plugged in. So maybe making sure, hey, plug your weather radio in. It's a low chance for tornadoes tonight, but there's still a chance, and it's enough of a chance that you should have your weather radio plugged in. And these people on the left, these are all some of the fatalities from the Cookeville tornado. And it's hard to say what they could have done when their whole house was wiped off the foundation. But maybe even something like, I would recommend not even going to bed. Maybe, and this might be reserved for more high confidence situations, which this one was not, but say, hey, watch the storms as they come in. Don't go to bed until the storms have passed. I don't know. And it's something that we like to think about and hope that we can message a threat so that we're not looking at a slide like this again in the near future. And I will say I'm very proud of our office because they did try to get that message out. This graphic they put out at 6:30 that night, and they explicitly said, be sure to keep your phone on and have a way to get your warnings while you sleep, which is exactly what we need to be saying. And they did it. And I went to the forecaster the next day and I said, that was great. Thank you for putting that out. And you see the graphic that she used, it wasn't the convective outlook, it was timing, which is very important. And she just kind of put her head down and said, I wish I would have put it in bright red letters. I wish I would have made this whole graphic say that. And I said, well, you don't know. And you did the exact right thing that you need to do. But to her point of how she wished that she had screamed the message out to people, I think goes to show that we need to, and not just put this out ourselves, but collaborate it. So if going into an event, you think it's important that people keep their phones and weather radios on, that we don't, not just we put that out, but our media partners put that out, that our surrounding offices put that out. Get as many people saying that as you can. Going back to the COVID-19, how many times have you heard to wash your hands and to socially distance over and over and over and over? So I think the more times that we get an important message out like that out there, the more likely people are to take it to heart. And that's why I put that here. The best service is a collaborated service. Collaborate your mesoanalysis. We had a lot of eyes looking at the situation that day, Memphis, Paducah, Morristown, maybe, I don't know, maybe not, but maybe someone could have looked like, hey, you know what? There's a little enhanced risk here that I'm seeing for a heightened tornado threat along this subtle boundary or along this, do you guys see this convergence line setting up? Do you think that could increase the tornado threat? And if so, Let's all message that together. And what are we going to message? Well, that could happen at 12:30 at night. So let's make sure everyone across the state of Tennessee is going to bed with their phone turned on, something like that. And we are actually trying that. We have set up a collaborative chat room that we've been using in the past few weeks with all offices that serve the state of Tennessee to exactly do that kind of thing. And so far, it's been very successful. And another item of encouragement, Southern Region Headquarters did do an after action review. And I actually meant to take this out. I meant this for Norman, but hey, I'll share it with another region as well. This is what is the draft version of the after action review. And I'm very encouraged with what they're putting in there. The number one recommendation is explore ways to communicate action. So instead of saying a slight risk has been outlooked over a large portion of our area for tornadoes, wind, etc., make your message explicitly, just come out and say what you mean. Please leave your phone and weather radio powered on overnight and be prepared to move to your safe place and shelter because we expect to be issuing tornado and severe thunderstorm warnings tonight. I think it's very encouraging to see that in a National Weather Service regional after action review. And again, my apologies to Southern Region, but I hope they don't mind me putting that in here. Another one is to collaborate this mesoanalysis, which is why we've set up this collaborative mesoanalysis chat room, which I think has been very successful, just based on our few instances of sharing it so far. And the human factors with us. We talked so much about social science with our users. What about our own social science? What preconceived notions could be in your head? If you walk in and you are outlooked for a 2% tornado and you've been assigned radar, and then you look at a forecast sounding with that subtle little stable layer near the ground, you are by nature probably going to be more conservative with your warning process. That's just how it works. And how do we overcome that? How do we break past these preconceived notions that the 2% might not, that might be more like a 10%? I think the mesoanalysis has a lot to do with that, but again, how do people incorporate that mesoanalysis into their decision making? How do you get people to even do the mesoanalysis? That can be a challenge in itself. That happens to drop off quickly in our severe weather duties. How do we keep that from happening? I will end it right there. Thank you, everyone. I'm very happy to be able to present to my old region. And here's my contact info and my Twitter